At Bing, we measure all the things all the time, so we know whether we're improving. Often those measurements involve crowd workers, and we aggregate the data they give us to make some sort of a metric. Now, in April last year, we noticed a sudden change in one of our metrics. Typically, this metric changes by about 1/10 of a point day to day, but we saw a 1.5 point shift overnight. That's an order of magnitude more than we expected, and it went away when we measured again later. We didn't change the component we're measuring, and we didn't change the way we measured it, but we do have one theory. A major religious festival started at just the time scores dropped. Festivals like that lead to changes in routine, like sleep patterns or diet, and these things are known to influence decision making. Of course, this is only a guess. We'll never know for sure what happened, but the point is we have this model of evaluation. The ranker produces some results, we give those to the crowd, we get back labels, we compute metrics, and the crowd is often treated like a peripheral. So we got crowd labels and then we did the interesting stuff. But of course, the crowd is made of people. And we still often forget, I think, that the crowd will act like people act. So how do people act? Well, we know we think differently when we're fasting. We know that judges in a courtroom are more likely to grant parole after breakfast and after lunch. We also know that they give longer custodial terms when their football team loses. And people comparing whiskies tend to prefer the ones they taste first or the ones they taste last. People have all these quirks, it's well established. But does it make a difference to our conclusions in IR experiments? What we did here is look at a bunch of data we've accumulated from all this measurement to see whether effects that are known from the literature from other scenarios are seen in offline evaluation too, and how big those effects might be. We looked at a few things. Today I'll very briefly talk about changes over time, fatigue, cognitive bias, and task switching. So first to time. What we've got are hundreds of thousands of labels for query document pairs, where each label is given by a crowd worker. We put those labels on a 100-point scale. Now, in the vast majority of cases, it shouldn't matter when the labels came in, 2 p.m. Tuesday or 3 a.m. Thursday. What we see, though, is a substantial and non-random effect due to the time of day. These are the deviations in mean score by hour of the day in the judge's local time zone. So at 3 a.m., we're about 3 points lower on our 100-point scale, and at 1 p.m., we're about 2.5 points higher. We see this even if we account for who is labeling. So it's not just that different people are working at different times, but the shape is consistent with the literature. People smile more during the day, for example. And we know that mood in turn influences judgments in other fields. So this all makes sense. But in our case, we're normally looking for differences of only a few points. So this is a substantial confound. And we've learned to be careful not to measure two different things at two different times. If you're only measuring once, for example, doing a single evaluation of your new system, then it's possible you'd never even know your results were unreliable. What else do we see? We see that because crowd workers are people, they get tired, like people do. What happened here is we looked at labels across a session, where a session is just all the labels from a single worker with no more than half an hour between them. What we saw was that the average score went up slightly across the session, and that the scores got less diverse, and that labeling got faster. So as people got tired, they kind of converged on saying, yeah, it's okay, yeah, it's okay, yeah, it's okay. And of course, because the crowd are people, and people have various cognitive biases, crowd workers have various cognitive biases. We see that in our data as well. We'll talk about a small number here, but of course, there are others. Anchoring. Now, when we make judgments in some dimension, we're swayed by an earlier reference in that dimension. We hold that first thing in our head, right, and make reference to it later, and that makes absolute judgments true. And we do see evidence of anchoring in our data. In particular, once people decide a label for the first thing they see in a session, they're more likely to use that label again. This is sort of surprising, but what seems to be happening is that people look for differences between documents they're seeing now and have seen before, and as many documents look sort of similar, the initial anchor just gets reused. The mere exposure effect says that we like something more the more we see it, and this is how I keep my friends, for example. We saw this too. We reduced all the URLs down to host names and looked at the number of times each worker saw each host. And bingo, there's about a 0.5 point shift on our 100-point scale each time a host is seen. So the second time you see a host, the score goes up by 0.5 point. By the 10th time, it's gone up 4.5 points. One last example of a cognitive bias, which our workers share with everyone else, Sometimes we ask people to compare two things side by side. Now, we know from the literature that when you give people choices laid out left to right, the left-hand side is preferred. The scale varies considerably, but this has been seen quite a few times, and we see it too. Here's a fun experiment. We took two SERPs. They're identical, except the one on the right is a hideous green. Of course, most people preferred the white one on the left. Only 21% said they preferred the green. But when we swapped them, that jumped up to 32%. So that's more than 50% growth just for being on the left. That's a pretty extreme case, but even in our most careful experiments with trained and audited workers, we see about a 2% bonus just for being on the left. And that's a big enough effect to sway things if the two SERPs are genuinely pretty similar and if you weren't being very careful in your experimentation. And we also need to recognize that crowd workers are working in a system we designed. A lot of the jobs are boring, some take a while to load up, and everyone multitasks. Workers on Mechanical Turk, for example, switch about every 5 minutes. And that's fair enough, but it does tend to reduce the quality. We looked at over 300 million tasks on our in-house platform from over 100,000 workers, and we do see that task switching leads to lower quality. As task switching goes up, accuracy goes down. But task switching is entirely rational inside the systems and the rules we've built. We don't want to punish anyone for this. We do need to bear it in mind. And one final thing, even taking into account all of these biases, fatigue, task switching, and temporal effects, relevance judges just don't agree anyway. Relevance is just hard to define. TEFCO has 4 papers surveying it. Google has 170 pages of instructions for their workers. We have 70, and the whole notion is very subjective. Therefore, judges vary lots, and it shouldn't be a surprise. On our 100-point scale, per judge averages range from 7 to 79. And judges disagree with themselves. For example, Scholar et al. Saw a 15 up to 24% disagreement on trick data, and that's big enough to change system orderings. So, where does that leave us? Well, these effects have caught us out more than once. But I bet other people have been caught out too. And importantly, at smaller scales, in academic labs, for example, these effects might well go unnoticed. But these effects are not just noise and they're not just error. These are effects we can predict and effects we can control for. We have examples in the paper, as long as we remember that the crowd is made of people.